Right. So this is my slide that I used to give a talk before. So why I'm showing you this, okay? Because this is actually part of analytical chemistry. I'm teaching biosensor and chemical sensor in another subject, but this is actually analytical chemistry, and this is among the reason that we learn about statistic, eh? Because we need to do data management, data handling, or data interpretation. Statistic is all about data. Okay, so we move on from benchtop machines, benchtop instruments towards smaller device, and now we can move to much smaller device. Okay, it can be wearable, in fact. So when we are migrating or developing a new method, okay, it is important for us to validate validate the new method that we develop, be it a new protocol, a new device, a totally new protocol of analysis. Because sometimes we have a new product, or sometimes we have a new faster way, cheaper way, so we can develop a new protocol. Okay, so all this while probably you are referring to certain manual, okay, but it's not necessarily the same protocol. Cannot be replaced. It can be replaced. You can develop a new method, but there is a standard way of doing. Okay, right. So I'm just showing some examples that this is the new things coming. Okay, all right. So these are all analytical chemistry, new machines replacing benchtop analysis. Okay, so this is very important. Okay, because if you don't know about all these things, then you will be left behind, because you think that whatever instruments that you're using in the lab, that's it. But people are moving to a smaller device, user friendly, and what we call as decentralization. What does it mean by decentralization? Is you don't have to be always in the lab. You can be somewhere else with this portable device. Okay, we have this AI, we have this remote sensing that you can observe the data in the office. So this is something that you need to know. Okay, why we use statistic as well? So this is also related to good lab practice. So I'm not going to talk about what is good lab practice. Okay. So we have discussed about this. We will learn in second part of statistic. So today is only basic statistic. So we have learned about the basic steps in chemical analysis. We start with defining the problem. Okay, we start with giving hypotheses, giving ideas, talking about what to do. Yeah, by defining the problem in front of us. So this is what we have discussed last week. We discussed the murder scene, remember? Okay, and then from there we know about the steps. Okay, let's skip this. Explain the correct sampling techniques. This one, I don't go detail, but enough for you to know that there are different kind. You have solid, you have liquid, you have gas, and there are many um, many protocols that you can use to sample solid, liquid, or gas. Okay, and as assignment, you will be reading. I will assign you to read between 7 to 8 for certain pages related to these sampling techniques. Same goes to sample pretreatment techniques. Okay, some general I will ask you to read for your between the 7 to 8 hours. I will assign the page and the reference has been given to you. Okay, so these are all some things that very important. Okay, before you can start thinking about developing a new method, a new protocol, and use statistic to validate the new method. Okay, so apart from just normal analysis, you can use this to develop a new method, a new protocol. Okay, once you have done the analysis, you get data. Okay, so the data has to be managed. The data has to be interpreted. The data has to be analyzed. Okay, it's not just data. You cannot get any conclusion from crude data, but it has to be analyzed. Okay, so these are the steps. Okay, this one we will skip because this is something that you have learned during your undergrad, and this is not very difficult for you to understand the definition and the basic units. Okay, in use in because in analytical chemistry there's a lot of calculation, so definitely unit is very important. So I'm not going to do this. These are all undergraduates, but I just want to show you that these are very important. If you forgot, then you have to do some revision. Okay, especially this kind of unit, molarity, ppm, ppb, because that comes in the question. Right? So normality, okay? Right, so this is unit calculation. Right, so this type of problem defining we have gone through. Okay, so now comes the data. Okay, you have done the analysis, you have defined the problem, decide on what method, and then you do the sampling. Once you do the sampling, you do sample preparation and do analysis, and now you get data. So what we will do with the data. So this is just a cartoon showing that the sun, he went through the data and found an 11.7% increase in the discretionary spending portion. Means that he found out that probably his parents are spending more. So I see no reason not to raise my allowance. So he stressed on his case, but based on evidence, evidence that his parent is spending, increase in spending. So he probably insists on the raise of allowance. So this is actually represent what we are trying to do. Once you get data, you can see, you can start to have a conclusion from the data. Okay, so from the conclusion leads to action. Okay, once you can conclude, you can lead to action, right? So data interpretation is the process of making sense, right? Making sense out of the collected data. So it is very important because if your data does not make sense, then the data cannot be used. Right? So in order to make sense of the data, we usually present it in a bar graph, line charts, or any different types of graphic presentations. Okay, so data interpretation involves taking the result, giving meaning to the data, and making inferences. So inferences is making conclusion. Yeah? Once you get data, you do analysis, you give meaning, and you can do inference conclusions, right? And based on conclusion, you can do action, right? So before we proceed to the basic statistics, a few understanding, because this is something again you have gone through during your undergraduates. Okay, so it's more like having a revision. Okay, so first, the most important word there are two: accuracy and precision. So very important to know what is accuracy, because in doing analysis, one of the ultimate aim is to achieve accuracy. How accurate your data, so how accurate your results. Yeah. So if you look at here, I'm sure this is something common. Your profile picture versus your real life picture. So how accurate your profile picture versus your real life picture. Of course, that depends, okay, whether you use filter or you don't use filter, or you prefer not your own picture, okay. But this is a reality. Of course, you want to have a good profile picture. In real life, you don't really care unless you have an interview or you're meeting someone special. Okay, so that's accuracy. Because why? If you're not really accurate, if you define the situation wrongly, okay, let's say this probably medical doctor define pregnancy as big belly, then it is might be leading to false positive or false negative. So how we characterize, how we interpret the data is very important, because if it is not accurate, then it leads to a wrong conclusion, right? So precision, yeah? Precision is how precise we can be. So if you can see here, if it is based on decimal points, if it is based on significant figures, you can see that it is very precise. The decimal point around 6, 23, 4, 5, 6, 8 decimal point. And you can see that this is an example. This page intentionally left blank. Well, it's not actually blank, but it would be blank if we didn't have to tell you it's blank. So it's very precise, telling you very detailed. So the other one is the usage of statistic is giving meaning to data. Okay, so now the other one, accuracy, precision, giving meaning to data. So whether your data is good or your data is not acceptable. Okay, for example, here the bar chart, the standard deviation, the error is too high. So these fellows said, sorry, we just can't trust you. Okay, your data cannot be trusted. Okay, so giving meaning to the collected information, purpose, and objective of the study should be closely referred and reflected in results and discussion section, because that is the final aim, to get a conclusion from the data to be in the results and discussion. Result and discussion section means probably if you're working, it's not what you think of. You might be thinking, oh, that's the data that I need to present to your top management. But in research, usually we mention results and discussion, because results plus discussion. Okay, right? Now, this is another possibility when you analyze data. After analyzing all your data, I think we can safely say that none of it is useful. So this is something that we do not want. So that's why when we do chemical analysis, regardless if you are developing a new method or routine work that you usually do, okay, probably you think about it. You need to sit down whether you are really solving the problem. Yeah, you remember defining the problem, defining, and decide on the method. The method must be correct. Or all this while you're using a wrong method. Okay, because you don't define the problem well. Third, of course, an accurate way of sampling, or the correct way of sampling. And sample prep also is very, very important. Okay, and after that you do the analysis, and you get data where you do data handling or data management. And of course, you come to conclusion. But before that, you do data handling plus all the statistical analysis. Okay, so conclusion here, we do not want this kind of conclusion where the data is actually not useful at all. Okay, so it's not just chemical analysis, because we are doing analytical chemistry. Of course, we talk about chemical analysis, but if you are doing survey, for example, if you are doing survey based research, this is also steps that you have to take. You define the problem, what method of statistic, what kind of questions probably suitable to be asked, and what kind of sampling, some people that you want to interview or you want them to do the survey. Okay, and then the sample preparation probably is not related, but of course the data requires analysis. So this one we have discussed in the first lecture. So there are certain precautions in data interpretation, even though we have some statistical methods being done. Okay, proper analysis through statistical method. There's the word that I errors are the major negative. All right. False. Yeah. Good homogeneity between the initial hypothesis, empirical observation, and theoretical concepts. Okay. Negative results are also part of study. Remember that negative results are part of study. You do not just remove them from the picture. It has to be considered statistically whether you can remove the data or you have to keep it. Yeah. Do not hide them, but try to combine with factual interpretation and pointing out the related mistakes. Yeah. What other word is bias? We, the operators, okay, try not to be biased. In data interpretation, the main precaution to be taken is to avoid discussing on a false positive or false negative results. Okay, we do not want false positive and false negative results. Errors are major culprits. Okay, you have to be cautious about errors. Okay, all right. If you are doing, for example, new drug development, and you have to do clinical study, okay, drug development, you have to pass the FDA, you have to do a lot of clinical study, which costs a lot, might be millions. Yeah, usually it's millions when you do drug study. So data from the clinical study is very, very crucial in order to have the conclusion, in order to get the conclusion whether the drug is actually good to go or we have to stop the production, or we have to do some reformulation or reanalysis again. So this is very crucial. Data analysis, data interpretation is very crucial, right? So this is just an example. In 2008, this famous singer, so it's drug abuse. All right, select a method. I just want to skip this, okay? So when we do data analysis, there are certain steps that we have to do. We have to do calibration, we have to do validations. Replicate is a must when we do analysis. Once you have the data, once you have the results, of course, there are certain formulation that you have to do for calculations. All right, so this one I have touched a bit, yeah, last lecture. All right, let's go. All right, so I'm not going to talk about significant figures. This is very undergraduate things that you have to look back. If your report are very crucial, then you have to think about significant figures when do the reporting. Okay, you can look at the summary examples. All right. So back to the precision and the accuracy. Okay. So this is the one that I've showed you is in picture form. So this is the definition. This precision describes the agreement among several results. So when you do replicates, it give you the it should give you the data should be close to each other if you do it correctly. If you have a very reproducible method, you do the repetitive measurement correctly, you should be able to get precision. Means that the data, I will show you an example later, that the data should be close to each other. So the agreement obtained, it should be very close to each other. Whereas accuracy is the measure of the value that we calculate to compare to true value. So is accurate or not. So when we do the analysis, for example, if the standard value is X, so if we calculate based on the analysis, it should be close to X, okay, right? So this is accuracy and precision. This is very famous picture showing how accuracy, how precision, and this is what we want, accurate and precise when we do analysis. Yeah, all right. So as one of the precaution in data interpretation just now is about errors. Okay. This is something that we cannot avoid. Okay, when we do chemical analysis, especially, it is prone to errors. So known as errors or uncertainties. Yeah. So is analytical result reliable? What is the maximum error that we can accept? Okay, because it's not going to be zero. It cannot be zero, right? So we have, this is also a revision. You have done this during your undergraduates. One is determinate errors or systematic errors, okay? So which arise from flaw in the measurement process, okay? And this kind of error is reproducible, means that it can happen again and again. All right, causes the mean of set data to differ from, yes, of course, this is the consequence from having this error. And usually it comes from three sources, usually instrumental error, human error, and, all right, why is it showing this back? There's another one. It can be also method error. Because if you choose the method wrongly, okay, as I mentioned, let's say you are trying to do gas chromatography, but the compound that you are analyzing is not volatile. Even if you convert into a volatile compound, it's not 100% volatile. So there's no way that you can do a correct or accurate analysis using GC. But that is not usually normal because you follow the right manual. But let's say you have a new compound, totally you don't know how to do it. So where do you start? Okay, let's have some questions. If you have a totally new compound, okay, let's say we have a new plant and somebody mentioned about that plant contains something very cytotoxic, means that it can kill cancer cell, for example. But this person does not know. He or she just consume the plants, and he or she observe that, well, this is not a real condition, getting better. And you as a researcher would like to know what is the active compound in these plants, okay, that have the cytotoxicity, which means it can kill the cancer cell. Okay, so where do you start? Any suggestion, Kamarul? Kamarul, where do you start?
I will start with literature.
Let's say, okay, well, it's correct. Okay, we start with literature. And next one, yes, Helmi.
Characterize.
Okay, what do you mean by characterize? Meaning that what step do you
Purification, meaning we separate from the whatever which compound it matrices in the plant, we separate to make it only single compound, and then that single compound we characterize what is the characteristic of that compound.
Okay. Some of you might have, thank you, both of you. Some of you might have studied what do you call that field? Organic, and it is in I forgot the, the field. Um, okay. So what they do actually, they just like Hami said, they do extraction. Okay. So the extraction must consider because you don't know, this is something new. You don't know whether the compound of interest is polar or non-polar or semi-polar. Okay. So you have to do a lot of extraction to get the active component out, and you have to do by using different kind of solvent. You have to do polar, you have to do non-polar, and you have to do semi-polar. Okay, so in order to do that, you have to mix certain solvent. But if you don't know anything about uh, mixing them, then it's quite difficult. But now we know there is a standard method on how to obtain the active component. So once you have that, the active extracted out in these three types of solvents, then we can do the analysis. Yeah. So usually, because to play safe, the best instrument we use is HPLC or LCMS, yeah, because we need to come up with a chemical structure, all right, to come up with the final chemical structure. So you extract, you purify, and then do LCMS. But not all of us, not all of our institution have this expensive LCMS. Yeah. So this is something I just want to talk about method error, because if you are working with a new compound, you're not sure which method is correct. Okay. So yes, we have to do literature first. But let's say there's no literature for this plant. It's not to say totally new plant, but people have not explored the plant yet. So it's actually you can do that, but you have to do a lot of analysis. Yeah. And if you have prior knowledge, okay, about cytotoxicity, then you know what kind of compound that have the cytotoxicity characteristic, and you know that compound probably in polar, uh, based on your understanding. So you start with polar solvent, for example. Okay. So instrumental error also. What do you think of instrumental error, Nadia? Where does the instrumental error comes from?
Uh, it can come from maybe the setting of there is some faulty with the machine setting
Yes, it's quite easy.
for the
Yeah.
or the condition and fluctuation.
Yes, yes, true. Okay, so that's why it's very important, maintenance, verification of machines. Even though it's expensive, you have to do calibration, proper maintenance of the machines. Yeah. So if it is requires you to do some verification, some calibration, and then please do, please do check on whether it gives a correct results or not based on standard material. Okay, but the one of the most difficult to to handle is human error. Okay, okay. So let's say you are the manager, Shahira. How do you counter this?
Um, Maybe one of it is having a competency test between all the lab technicians, so we know how far that they can handle all the machines
Yeah.
and give trainings.
All right, good. So this is something that we can solve. Okay, we actually can trace the errors. So that is systematic and determinate errors. We can trace the error. Okay, we can have suspicions and we can trace. Okay, this is due to instrumental error. This is due to wrong method being chosen. And if you observe, your colleagues, not your colleague, your probably your staff is doing improper uh, standards in the lab, so you can have them be retrained. Okay, but what about if we have why is it moving back? uh, uh, Indeterminate errors. uh, what do you think, Pavitra?
Determinate error. Maybe we don't know what are the consistent error there.
Yeah, we don't know. It's difficult to trace, but examples, any examples that you can think of? It can be temperature. Sometimes it's as simple as temperature, because we usually the protocols give us it is run in room temperature, for example. It is run at 25 degrees. So it's difficult for us to maintain the 25 degrees. And also it's difficult for us to maintain room temperature because it fluctuates. Okay, so that is condition as well. And we also know that even instruments comes with error. Each instrument comes with error. Uh, this is something unavoidable and it's hard to trace. So that's why in order to solve this kind of errors, we need to use statistic. So this is the one that we are going to discuss, which is statistical analysis. This is to minimize the error. Okay. So this is something we start from, not to say scratch, very basic. The first one is mean. So I'm sure mean is something is average. You can calculate the average very easy. Okay. So I'm not going to explain to you how to calculate average. The next one is how to calculate standard deviation. Okay, so I will show example in the module. Okay, how do we use the formula calculating standard deviation. But all this can be done by using Excel, okay, or any other software that you can do. So that's why I mentioned in my first lecture that you do not have to worry about you have to memorize the formula, because all this can be done through Excel. And if you have a proper software, please do, because this is not to test you how to use your memory, how to test you on how fast you can do the calculation, but it's for you to understand the usage of these statistical means. Yeah, right. So standard deviation, yeah, this is if the sample is more than 30. Okay. approaching infinity. So this is the one if you're talking about less than 30. So this is also standard deviation, but different symbol when your sample, which is n, more than 30. But this is standard deviation if n less than 30. Okay, some of you are probably more expert than me. Sometimes we forgot to use this. When we have data, we are happy, but we forgot to do some statistical analysis, which is very important because it will probably show a different conclusion if we carefully analyze the data. Okay, so this is standard deviation. Just now is mean average. Okay. So not that difficult, but you do not need to do the calculation. Okay. It's easy if you just learn Excel or any other software, you can generate the standard deviation. Just familiarize the term because probably you have forgotten mean, standard deviation, and if it is standard deviation S squared, it's called variance. Yeah? So memorize back the term. And error bar, because error bar is represented by mean plus minus the standard deviation, because this will show how good your analysis is. If the error is high, then it should be, you have to read, if it is too high, usually if it is above 5%, depends. Sometimes people don't want even more than 1%. If it is above 5%, then you have to do the analysis again. If not, it is not acceptable. Yeah? Right, bad data. Okay, the error bar is very big. Okay, and then when you get data, okay, we have this what we call as Q test. Okay, in order to evaluate whether the data that we obtain is all good. There's some outliers. Well, weird outliers, and we need to consider whether we have to remove that data from the set or we still have to retain the data from the set. So we use Q-test. So again, if you, Q is very easy, the easiest among all the t-tests, all the analytical, all the statistical. So if you look at here, 2.56, 2.7, 3.01, and until 5.34, definitely the suspicious data is 5.34 because it's too far from the, if you calculate the mean, you can see that 5.34 is, the value is far from the mean. So in order to do Q-test, this is the formula, the easiest one. A is the difference of the suspect value from its nearest one. So 5.34, the nearest one is, not to say the nearest in terms of value, not on the location. So the nearest will be a 5.34 minus 3.11. Okay. And the W is the range of the values. Okay. 5.34 minus the biggest difference. Okay. Yeah. Right. So when you calculate Q, you get this value. Right. So we have to look at Q table. Okay. This is something that you have to, if you forgot, then you have to look back how to read the table. So this is the table. You have to decide at what confidence limit, whether you want to use 95% confidence limit, 99% confidence limit, or 90%. So let's say we use 95%. Let's say 95%. Okay. Is the question using 95%? No, it's not mentioned here. So let's decide on 95%. And what is N is number of samples. Okay, so number of data. So how many we have? 1, 2, 3, 4, 5. So 5 So the value of Q from table is 0.710. So now we have Q from table 0.7, and we have Q calculated 0.802 here. Okay. So since Q calculated is bigger than the Q from table, okay, so reject we can remove the data from the data set. Okay, so this is a very simple way of evaluating whether you can reject or you have to retain the data. So this one, again, another example. So I'll just skip this, right? So the first hour, we've just finished the definition. And the second, the 8 to 9 session, we will do the module. We will discuss a detailed example of how we use it in the actual question, yeah? So the second test, now our data are good. We have removed the outliers, or probably we have retained the outliers. Now we are comfortable with our data. So we do statistical analysis. Why? Let's say, so if you read the textbook, okay, I hope that you go through the textbook. This is one way of comparing. Okay, as I mentioned before, you can do method development. Let me okay, you want to develop a new method. Okay, so let's say in the lab, for example, you have standard way of testing. Well, the best one is glucose. Okay, you have a standard way, but probably you want to develop a new method versus the standard. Okay, so now you come across a new reagent that can replace the enzyme. Remember that glucose analysis usually use enzyme, but you find a new chemical reagent which is cheaper, more stable, and you want to develop a new method. Yeah. So in order for you to develop a new method, you have to do the analysis, right? You have to do the new developed method, and you get data. All right, from here you get data. And you have to do the same sample from the standard method. You'll get data. So data A, for example, and data B. Okay. Before you can say that your new method is good to go, we have to do a comparison with the standard method. And there are a few tests that you can do. One is the F test. Okay, the F test. The F test is to look at the precision. Remember the word precision just now? Precision, right? So we look at how precise our new method, data from the new method versus data from the standard method. When I say standard method, means that it is an established, how people has been using it. It's in the reference book, for example. So this is about the precision. Okay, so this is the formula. Don't worry, we will do the real example in the 8 to 9 session, right? And we will discuss this later. And another one is students' t-test. Okay, so back to the analysis just now. Okay, so one is F-test, is to evaluate on the precision. Number two is t-test, to evaluate on the accuracy. Accuracy is comparing to the true data, true value. Okay. F-test is how close the data with each other. Okay. So these two tests, including the Q test just now, are very important when you do chemical analysis, whether you're doing a new method development or you're just doing routine analysis, and one day you have suspicions about the data, so you can do statistical study. Okay, all right, so we'll do the example in from 8 to 9, but during your 7 to 8 session, I would like you to read. Okay, let me, where is it? Okay. Okay, just to test your own understanding. Okay, first you have to ask yourself, okay, differentiate grab sample. This is from last week. Gross sample, lab sample, and analysis sample. Okay. Number 2 is, let me check, I have jotted down just now. Okay, you read sampling preparation. Okay. This is from GD Christian, the book that I have shared with you in the Putra Blast, also in the WhatsApp group, I think. You can read chapter 2, starts from page 49. Okay, so you can have a protocol in sampling and how to generally prepare the sample. It's not specifically for, yeah, some of it related to extraction, but these two are very important for you to understand the first lecture. Okay, so and in the end of the 8 to 9 also, we'll give you some take home to think about, but this one enough for your 7 to 8 break. Just look through the information. Okay, so I think we can take a break. So this one, we look at the examples on how it is used with some calculation. Yeah. So I also have given you an assignment, sort of, for you to look at between your 7 to 8 break hour. So I hope that by now you at least can differentiate between grab sample, gross sample, lab sample, analysis sample. Okay, and I have also given you to read chapter 2, page 49, particularly on sampling and sample preparation in general. I believe it is quite general. The book is already in the Putra Plus. So this is a module, a detailed module on how to use the t-test and the f-test as well as the q-test. So the first one is, if you look at ways of expressing accuracy, so there are absolute error, mean error, relative accuracy. So this is all the formulas, and those who are empty, like this one and this one, yeah, also this one, please fill up, yeah, by yourself. Right, so let's move to standard deviation. So we know standard deviation represent precision, whereas accuracy represent means represent accuracy. So the formula, I think you have done already. So look at f-test, test of significance, how we use f-test. So evaluate the difference between the spread of the results, which is the precision of the results of the data. So let us familiarize ourselves with the formula. Okay, so this is F formula, and it is based on variance. We know standard deviation. Variance is standard deviation squared. Okay, and the value of F has to be more than 1, cannot be less than 1. Okay, so let's familiarize again yourself also on degrees of freedom, psi 1 and psi 2, where degree of freedom is defined by number of data sample set minus 1. Okay, so you have to familiarize yourself. This is also possibly you have gone through during your undergraduates, but this one is a repetition. Okay, but it's very important because whenever that you do analysis, let's say you want to validate between the the standard material, for example, we can do this. Okay, this analytical statistical test. And you have to familiarize yourself with the usage of values of F from the table. Okay, F table. And in the end of the lecture, I'll also be giving you assignment to do by yourself about confidence level. Okay, so now this is degree of freedom. Okay. All right, let's clean that up. So look at the questions. So this is one example, the usage of F-test. Okay, you are developing a new colorimetric procedure, okay, for determining the glucose content, okay, the famous glucose content of blood serum. Okay, so you have developed a new procedure, and you have chosen to validate against here is standard Fulling-Wu procedure. Okay, because in order to verify your new method, your new protocol, your new procedure is valid, is credible, then we have to validate against an established method. Okay, so as I mentioned just now, you have to do both analysis, your new method and the standard method. Okay, you can see that the numbers are not similar in terms of n. For the new method is 1, 2, 3, 4, 5, 6, 7. Okay, let me put it new. Okay, new. This is n from standard method. We have 6. Right? So this is the meaning of n. And in order to calculate f, you have to do all this calculation first. We have to find the standard deviation. Okay, so this one you can do the calculation by yourself. Okay, remember the formula of standard deviation, but since we are using variant, okay, so it is S squared. Okay, so again, you can use software, you can use Excel to get the value of variance. As long as you get the value correct, then it's fine. Okay, it's not necessarily that you write or you calculate manually. This is not the importance of this subject. The importance of this subject is for you to know how to use F-test. All right. Now, so for you to assign which S is at the top and which S at the bottom in the in calculating F, you must remember that F has to be bigger than 1. Okay, so it's not always developed method on top or standard method at the bottom. So we have to look at the value. So if you look at the first variance, okay, so this is based on new method. Okay, so 8.3, and the standard method Fulling-Wu is 4.8. So means that you have to put the variance of the new method on top and the variance of the standard method at the bottom, because in that way you get value more than one, right? Okay. So now, once you have the arrangement correct, okay, so you calculate the value of f, right? And you have to use the f table, okay? So now you know that the S new is at the top and the S standard is at the bottom. So it means that you have to decide the psi 1 is related to the new method, okay? Whereas psi 2 standard method, okay? So it's degree of freedom. So what is degree of freedom? So psi 1 refer to the number of sample, because its new method is 7 and minus 1, so 6. Psi 2 is 6 minus 1, it is 5. Okay. So now, why do we need these values? Because we need to use the F table, right? So look at the F table. I think the F table is down here. Where is it? Eh?
I think on top.
On top, yeah. Yeah, okay. So now we know the first value, the first degree of freedom just now is 6, okay? And the second degree of freedom just now is 5. So based on, this is already a 95% confidence level table. So the F from table is 4.95. So let's look at how we conclude in the end, all right? So the table, the F value from the table, okay, as I have pointed out, is 4.95, and the calculated F is 1.7. Why is it the 3 is small? Is due to significant figures. Okay, so I think you have to read significant figures at your own time, but it's not for you to worry. It's not going to be in exams or whatever, but it's important you learn about significant figures. Because the F calculated is 1.7, which is lower than F from table, which is 4.95, we can conclude it. Okay, this is very important, the conclusion. We can conclude that there is no significant difference in the precision of the two methods, which is a good news. That is a good news, all right? This is what we want to know. If there are any difference in the precision first. Is there any difference in the precision between the two methods? So the standard deviations probably are from random error and does not comes from determinate error, okay? And don't depend on the sample. So this is the first conclusion before we can proceed to the t-test, yeah? All right. So as I mentioned, not to worry on how to calculate the standard deviation, the variance, because you can use all tools that you have, whether it's Excel or using other software. Okay, so now we are happy with the F-test. If the F-test pass, then we can proceed to the t-test. Okay. The t-test, there are three different types of t-tests. Where is the table for t? This is Q. I have to find it from the lecture slide. This is that, right? Okay, let's look at t-test, right? There are 3 types according to the GD Christian book, okay? T-test when an accepted value is known. This is quite easy. So if you receive a material, okay, what is common material that you do quality control? Can you name one in your factory? Anyone? Okay, let's say look at the example. You are developing a procedure again. It's not necessary you are developing a procedure. You just want to check whether the label, because you bought the chemicals and the label claim it has 70% your interested element in that particular container. So you want to check whether it is 70%, okay? Because you receive that and you have to check as a quality control, you have to check the claim whether it's 70%. So you are developing a procedure to determine traces of copper in biological materials. And this is the preparation of sample using wet digestion. And you are using a technique called AAS, atomic absorption spectrophotometry. In order to test the validity of the method, means that because in this case you are developing a new method, you obtain a standard material. This is standard material means that it is validated, okay? Standard reference material, and you compare the analysis of these two. So 5 replicates are sampled and analyzed, and the mean. So in this question, the mean is calculated for you, which is 10.8 ppm. And standard deviation also is given plus minus 0.7. The listed value, okay, the listed value means that the claim, if you observe at the container, it is claimed that 11.7 ppm is probably the traces of copper in that biological material. So now you have that's why we are based on the true value here. T-test when an accepted value is known. So not all the time you have this. In this case, you have the true value, which is 11.7. So this is the formula of T, okay? X bar is mean, okay? Mu is true value, listed value. There are a lot of names for this mu. True value, listed value, reference material value means that there's a standard value that you are referring to. Of course, N is the number of sample and S is the standard deviation. So just use this formula. So plus minus here is not you plus, it's not you minus, but it's the value of the S. Okay, so you can see here, we just put everything in because the question has given the 10.8 is the mean and 11.7 is the listed value. And you have 0.7 as the standard deviation and 5 as the sample numbers. And according to the calculation, we have 2.9, or in significant numbers is 2. In significant figures, the correct significant figures is 2. 1 significant figure. Right. So how do we solve the conclusion? So there are 5 measurements, okay? 5n, n equal to 5. So the degree of freedom is 5 minus 1, yeah? From table 3.1. Okay, it's not in the module, supposed to be. So the value is, the degree of freedom is 4. Okay, so let's search for, I don't have it here. This is Q, right? Let's go back. Right. Then, yeah. Let's check on the table. Fine. Where's the PowerPoint? Okay. I think I have the table here. This is F table.
Doctor, is in the slide 79, Doctor.
Is this one, right?
79.
79. 79 is the formula.
Mine given 70.
This
It's
one.
before. Yes. Oh, 93. Sorry.
Thank you. So just now the degree of freedom is 4, right? So the degree of freedom is 4. And I forgot. What was the confidence level? 95, right?
Yes, 95.
Confident level.
So the value is 2.776. Yeah, it should be correct. Okay, so I think it's quite easy now. You know already how to read the table. Okay, where does the... All right. Perspective. Okay. So now, okay, here. So from the table, we can have, we know that the T table is 2.776, which is less than the T calculated. Okay, so T calculated is 2.9. So there is a determinate error in the new procedure. Okay. Usually I prefer to use T calculated bigger than T table. So there is determinate error, meaning that we know that determinate error can come from procedure method, can come from the instrument, can come from the operator. So there is determinate error. That is a 95% probability that difference between the reference value, the value listed on the container, is not accurate, or probably your method is not accurate because this is a development of a new method. It's not due to chance. There is an error, determinate error happening during the analysis. So this is the conclusion from the first t-test. Okay. So there is another t-test, comparison means of two samples, where the t-test is applied to, it can be 2 sets of data, it can be 3 sets of data, or more than that. Okay. But usually it's 3 sets of data. And why we do this, okay? So if you look at the example, the second t-test, okay? A new gravimetric method is developed for iron 3. And this is the description of the method, okay? So the accuracy of the method is checked by analyzing the iron in an ore sample and comparing with the results using standard precipitation. So this is the standard method. Okay, so let's say it's not about developing a new method. It's about doing an analysis, and we want to be, we are using the same standard procedure, okay? But we have different lab. For example, lab 1, let's say company 1, lab 2, lab two from company two. Okay, you're doing analysis, a very expensive one, and you want to be very sure. So you have the samples, you send to 3 accredited labs, okay? Okay, and they are using the same procedure. So you can use this t-test as well, okay, to compare the accuracy of between these three, okay? So, but in this example, still we are using a standard method against a new method, okay? So apart from that, you can use this t-test to compare results between different labs, different sets of analysis, not necessarily a new method. Okay, right. So what's the difference between the above one, which is the first t-test, which true value is known. This one, the true value is not known. Okay, so we have to use what we call as pool standard deviation. SP stands for pool standard deviation. Okay, so the formula is, yeah, it's very long. It's just like a series of standard deviation. Okay, so I'm not going to ask you to calculate because, again, this is not a test of calculation. This is a test of how you understand the usage. So let's look at how the second t-test is handled. Same procedures. You have in here the test method. You have 6 n equal to 6, and the reference method you have n equal to 5. 1, 2, 3, 4, 5. Okay. So what you want to know whether you have a significant difference between the two methods. Okay. So let's say you have comparison between this lab just now. You can do that. You also can evaluate the is there a significant difference between these three accredited labs because you send the samples, yeah, to them. Right. So this is the calculation involved. If you are to do it manually, okay. This is the procedure is you have to do the F test first. If the F test pass, then you do the T test. So we just skip to the T test. So you calculate the SP, pool standard deviation, and then in the end we get the value of T, okay, using the formula for T calculation just now. It's just that the S is replaced by SP. And from the tabulated T, okay, it's just you have to use this as the degree of freedom, which is just now 6 plus 5, right? 6 plus 5 minus 2. So it's because 2 sets of samples. Okay, 6 plus 5 minus 2. So that's how you get the degree of freedom. So let's say 95% confidence level. And if you refer to the T table just now, okay, once you have the degree of freedom correct and the confidence level, then you get the T value. Now, if you look at the comparison of T calculated, which is 1.23, and T from table is 2.262. So T calculated is less than T from table. Then the conclusion is there is no statistical difference in terms of mean. If you want to be specific, in terms of accuracy, in terms of mean, comparison in comparing the two methods. Conclusion is very important when you are answering T-test, F-test, Q-test, because that is the ultimate aim. You want to conclude. Okay, right? Okay, any question up to here? Okay, so far so good. Right. So now there's a third one. It is called PET T-test. Yeah. So PET T-test. Again, a new method. Okay, it's always a new method. What's the difference between PET t-test? You can do multiple analytes. Okay, right. So just now, we are comparing a single analyte. If it is iron, it's only iron. Here is iron, right? And here is glucose. Okay, but for PET t-test, if we look at the data, okay, this is PET t-test. If you look at the data, you can have a different sample. Okay, you are developing, okay, let's look at example. You are developing a new analytical method for blood urea. Okay, blood urea, you want to determine whether your method differs significantly from a standard one for analyzing range of sample concentration expected to be found in routine lab. So it has been ascertained that the two methods have comparable precision following other two sets of results. So you can do multiple analytes. Okay, you can, by having PET t-test, you can do multiple analytes instead of just single analyte, but the procedure is the same. Okay, this time we are using SD. Okay, so the first one S, second one SP, and the third one SD. Yeah, PET t-test for SD. Right, so the formula is the same as long as you calculate the SD and then you get the value of T. Similar steps, you have to find the degree of freedom, 5 degrees of freedom. Why is it 5? 1, 2, 3, 4, 5, 6. So 6 minus 1. In this case, you don't have to. 6 plus 6 minus 2 is 6 minus 1. So if you look at the value in the table is 2.571. So T calculated, which is 1.63, is less than 2.571. We can conclude that there is no significant difference between the two methods. There is no determinate error happening during the analysis, and it's a good news. It's a good news for you if you are working with new method. Okay, so there are 3 types of t-tests. Yeah, remember when you have sets of data, you start with F. F test, evaluate the precision. How good your distribution of data compared to the standard method that you have chosen. Once that pass, you choose t-test that is suitable for your application. It's either t-test when the value is known, or comparison of mean of 2 sample sets when the true value is not known, and the third one is PET t-test. Okay, this one we have discussed just now. Any question before we look at the last example of Q-test? Okay. All good, yeah? All right. So again, this is similar to what we have discussed just now. This is just to repeat how do we do Q-test, but I forgot to remind, Q-test has to be the first one. Q-test has to be the first one before you do F-test, T-test, because Q-test is for you to evaluate outliers, whether you want to discard the data, some of the data, or whether you want to retain the data. So look at the second time we look at example. The following set of chloride analysis on separate aliquots of whole serum was reported. Okay, so one value appears suspicious. Suspect, determine if it can be ascribed to accidental error at the 95% confidence level. Okay, so the suspect is 114. Okay, how do you know 114? if you're not sure, you calculate the mean, okay? And the value that has the largest difference with the mean is the suspicious one, okay? So it differs from its nearest neighbor is 107, and the range is the nearest and the biggest range is 7 and 11. So Q, just like what we have discussed in 7 to 8 session, you can have the value of Q by calculating the smallest difference over the biggest difference. The tabulated value, Q table, is 0.829. So since the calculated Q is less than tabulated Q, the suspected number may be ascribed to it. Okay, means that the data should be, the data or the figures, the numbers should be retained. Yeah? It cannot be disposed from the data set. Okay, right. So I think that's it from the analysis example for Q test, F test, and 3 types
Doctor,
of T test. Yes.
can I ask about the tabulation of data
Mm,
for the Q test?
mm.
The Q test only going to be performed when we are suspected they are liars for the of all the data. If let's say for all the data they are very precise, they are same, maybe not same but it is near to each other. So we don't have to perform Q test. So we can just continue using the data.
Yes,
We
yeah.
still need to perform Q test to like confirm.
If you have suspicious data.
Okay.
Okay.
All right.
Yeah, right. Okay. It's not necessary, but only if you have suspicious data, because after this t-test, let's say you need to do calibration plot and whatnot. If you have these outliers, then you have difficulty in getting, okay, we will learn about regression, linear, linearity of the plot, calibration plot, so that will affect, okay? All right, so all these tests, because we are doing chemistry, this test suits us because we're not working with a lot of samples. I don't know, any of you are working with biological samples? Means a lot, like you do with plants or cells? Anyone? Okay, because in those who are working with biotechs, biological compounds or plants, they do work with a lot of samples. So usually when this type of this statistical does not suit the analysis of a lot of samples. I would say that's why we have later somebody talk about ANOVA, okay, which is suitable for samples, for a lot of samples. So this one is enough for you if you're doing chemical analysis for 30 or probably a bit more than 30. But if there is a lot, then we should be using a different type of analysis, statistical analysis. Yeah, okay. So let's done this. Okay. We stop at done this, all this. Okay. Right. It's okay. So I want you to read something, not just the one that I have mentioned for you to search during your 7 to 8 session. Some of you might not have the time to read, but please do read, yeah, especially the GD Christian on the sampling and the sample preparation, okay, page 49. But also after this, okay, you should also read on confidence limits, which we don't discuss, okay, but very important, confidence limit. It is in chapter 3, GD Christian as well. Okay, page 84. Okay, so this very simple calculation of confidence limit. Okay, the one that we discussed is now 90%, 95%, 99%. So there is a calculation on how to get the confidence limits of an analysis. Okay, so please do this and the one that I mentioned just now. Okay, so do at your own time. Okay, so I hope this covers the basic statistical that you need to do if you're developing a new method, if you're doing comparison with your if you are using standard method but you want to compare with other labs or other companies, okay, so you can do this statistical analysis. Okay, questions before we end? I think we end early.